welcome to one expert video tutorial, still under calculus 2, our second video. So now we are going to look at integration by substitution, and see it's the same integration that we have been doing from the first video, but here not all the integral functions that you can integrate it just by what you know for now. Okay, sometimes we need to apply our idea, that is integration by substitution, or normally people call it U substitution, in order for us to arrive at our answer. So now, for instance, if you have integral of s squared minus 1, we'll go to the step. Okay, but I want to introduce something to you. Raised to the power 2x ds. Okay, now from what you know for now, if I give you this question for you to solve for me, I know the only thing that you can say is that, okay, let's expand and simplify. So after expanding and simplify it, then we can now apply the integration and integrate it with 10 by 10. I won't challenge you, alright? I won't challenge you. You are correct. You can expand and simplify the inside and take the integration 10 by 10. But what if I make here 20? What if I make that place 60, 70, 80? Oh, my friend, you will die. So this idea is somehow relating to our calculus 1, where we apply chain rule or general probability rule. So it's all about what? Powers. Alright? Very good. So looking at this, the step says that first you pick U, so that integral is what? Easier. You are going to pick U so that the integration will be what? Easier. I will do it for you to see. Usually the inside of something, usually the U is always inside of what? Something. Example, it can be in a bracket or what? A square root. 3. Yeah, that's 3. 4, 5. 3. Translate. So when you pick the U, you differentiate the U. So you translate the integral. This integral is in terms of what? S. You translate it to what? U. You translate it to U. I will take you through how we translate it and all that. 4. Do integral. So you do the integral as respect to what? The U. So your result is going to be in terms of what? U. But when you are done, you need to translate back to what? X. By doing the what? The substitution. Alright? It's not anything difficult. Let's move on. So now here, in fact, you're going to solve a lot of questions, and it will equip you to get more understanding or concepts. So U will be equal to, we are saying that the U is always inside of something. So the U cannot be 2s, it cannot be not make that. But the inside, which is what? S squared minus what? 1. Then you take the derivative, du ds will be equal to what? 2s. You know when you differentiate this, you get what? 0. Please calculus 1, go back. Therefore, then you make the s the subject because we want to go and do substitution into this. So we need ds. So ds. To get ds, cross multiply. Okay, so you get du over what? 2s. Now that we have dx down, then we go and do the substitution back, knowing that this one is going to give us what? U. And this, let's go. So here we get u to the power 20 2x ds, and the ds is what? Du over what? 2x. Now, since we are saying that we are to translate the integral in terms of s to u, we need to cancel out any s that will appear in the what? In the function, and not just cancelling it that, way. You should follow a rightful procedure, and the procedure is that That is why you pick the right u. If you don't pick the right u, then your integral function will still be remaining with what? S. But if you pick the right u, it will clear off like what we can see what here. So we will not be getting anything of s again. And let me give you one technique. You know that anytime you take the derivative, a power reduces. If you have s to the power 4 and you take the derivative of it, the power will reduce to what? 3. If it's 3, the power will reduce to what? 2. So the moment you see s, the inside here, the power is 2. And the outside here, the power is what? 1. That means that, see the technique, that means that you pick this to be u and you differentiate it. You are going to get the power here to be the same as the power here. And you see now that it can cancel out. I hope you can see that. I'm giving you a very important thing here. Now let's assume here is square. If here is square, that means that here should also be, let's say, power 3. Okay? It should sometimes, normally it is above of it what? 1. Here, the power here is above of the outside what? 1. So looking at this one too, when you take the derivative of this, you get what? 3s squared. The emphasis is on the power. So the power will be what? 2. So that 2 will also come here and cancel out when you get to this part. Is that correct? Thank you for your understanding. Alright, so the 2 will cancel. Then we are going to be left with u to the power 20 du. So this is how we translate from function in terms of s to function in terms of what? U. Then the next step says that do integration. So when you do the integration, you know that here the integration is what? Easier. That is why you pick u, so that the integration is what? Easier. So when you integrate this, you get u to the power 21 over what? 21 plus c. Always don't forget. Translate back to x. So this is our results, alright, but we need to translate back. So back, u is equal to what? S squared minus what? 1. So by substitution, we get s squared minus 1 to the power what? 21. All these over 21 plus c. Beautiful, beautiful. I hope you can see that. Alright, so this becomes our final answer. Please, it is indefinite what? Integral. So you need to bring the word plus c. Why do we see that it's indefinite integral? When we get to definite, you see the difference between indefinite and what? Definite. Okay, so that is that for that. As I said, we are going to solve a lot of questions. If you don't understand anything, pause the video and play back as many as you can. Alright. Example 2. With this question, if you want to expand and simplify, then you will die on your way. I hope you can see that. Alright, so what we have to do is that we have to pick u. And how do we pick the u? As I said, always check the power, and the one that you are picking, the u. The power of the u, the power of s in the u should be above of the outsider one. So you can see that if you pick this as your u, this is square and it's not above this. So when you pick this to be your u, and we say that the u is always inside of something. So u is equal to s to the power 3 minus what? 4. Minus 4. So your du ds is going to be 3x squared. This is 0. So your ds is just equal to du over 3x squared. And now we are going to use this and this to do the substitution. So you can see that we get integral of what? S squared Then here is u. Then power 5. ds is what? du over 3n squared. So clearly, this is going to take away this. Beautiful. And we have a constant inside here. And that constant is what? 1 over 3. So the 1 over 3 will come out. Then the integral sign will come. U to the power 5 du. You see now the integration is easy. Alright. So we get 1 over 3. Integrate this. You are going to get u to the power 6 over 6 plus c. So here we get 1 over 3, 6, 18. 18 u to the power 6 plus c. So but u is what? That is exactly what we have here. So s to the power 3 minus 4. And that is going to give you 1 over 18 s to the power 3 minus 4 power 6 plus c. And that is your final. In fact, it's not difficult. I love calculus. You see how it is? Alright. Let's look at our 10 example. As I said, you are going to run through a lot of questions. Alright. 3 integral of 2s to the power 3 sine. You see, I can make here 2. I can't do that. Why can't I? If you pick, the u should be something that the power will be what? Above the outsider one. And the u is always inside of something. This is not inside of something. And even if you pick u, how come will this come and cancel the inside of it? It can't happen. Because this one here is an argument, alright? It's an argument. So nothing can come and cancel it. So that is why if you have, let's say, cos s squared over s squared, you can't say this will cancel this. What we have there is an argument, so it can never cancel out. So here will be power 4. Alright. So you pick u to be s to the power 4, du ds. Sometimes you can choose not to write du ds. You will just write du is equal to 4s cube ds, knowing that du ds, if you divide, so when you multiply, it will come to this side. It's the same thing. So we get ds to be equal to 4. The more you try your hands on more questions, the more the techniques will come. Alright. So we divide both sides by what? This. So we get du over 4s to the power 3. So by substitution, we get 2s to the power 3 sine u du over 4s to the power 3. So this will cancel this. This goes here 1, this goes here 2. And the constant in this is 1 over 2. Integral of sine u du. Beautiful. Alright, so here we now see that the integration is what? Easy. Because we all know the integral of what? Sine u. Please, you cannot make here integral, the integral function cannot be in terms of u and you will still have the s here. It doesn't make sense, alright? So, or it doesn't, it's not mathematically what? Sound. Alright. 1 over 2. When you integrate sine, you get what? Negative cos. So negative cos u plus c. But u is equal to s to the power 4. So half cos s to the power 4 plus c. And that becomes the final answer. We will solve a lot of questions, don't worry. Four. Alright, so having this, how are we going to do about it? Think of it, or start to try and solve and see what you are going to get. I'll be back. Alright, so here, as we said, it's an addition, so we can split it and integrate it term by term. So we integrate 1 over s squared ds plus integral of s squared pi s ds. Please, the pi here is a constant, so don't be scared, alright? So now, having this is, you need to be in that form. And here, all we know what it's going to be. I'll come back to it. Sec square by x ds. Okay. So when you integrate this, you're going to get negative s. So you add 1 to this, you get negative 1. Divide by s, that's what you're going to get. Plus, you need to integrate this, alright? But before you integrate this, you can see that something is inside here, alright? And this is not just an argument. Now let me explain something. Do you know why? When you integrate, let's say sine s, you are going to get negative cos s plus c. Do you know why? We can say that this is inside of this, so we set u to be equal to s. And this you are going to get du to be equal to what? ds. I hope you can see that. Because in case you don't see ds, here is 1. So by cross multiplication, we get du to be equal to what? ds. Very good. So by substitution, we get sine u du. And when you integrate this, you are going to get negative cos u plus c. And u is what? S plus c. Now, can you see that? When we say this to be equal to u, you just get u to be equal to ds, which in another case, when you integrate this straight away, it will not affect your what? Your results. Because even if you do by substitution, you get the same thing. You cannot apply the same idea to what we have here. We all know that when you integrate sec square x, you are going to get tan x. But this is not just sec square x. This is just sec pi to s. So this, you can't say that the result will be tan. Since if you integrate sec square, you get tan. But don't forget, that is sec square x. This is not sec square s. So you can say that you get sec square x. So here you get sec pi x plus c. No. When you do that, you are making a mistake. So here we have to take our time. We have to take our time. Set u to be equal to pi x. Du is equal to what? Because when you take the derivative of it, this is a constant. So you get the pi. ds. Okay, so ds will be equal to pi du over what? Pi. And when you do the substitution back, you are going to get integral of sec square u du over, because that ds is du over what? Pi. You see that something is happening. So here the constant here is 1 over what? Pi. Integral of sec square u du. So we get 1 over pi. Sec square, when you integrate, you get tan u plus c. But u is pi s plus c. Now you see that we are getting the constant which was attaching with the what? The variable s to be 1 over. So to say that this will be tan of an argument pi s is wrong. So be careful about that and know how you treat that. So therefore the final answer is going to be negative 1 over s, because with this we can write this as this, plus then you bring 1 over the pi tan pi s plus c. So this will be our final answer. So quickly note that if you have sine 3x, integral of this, straightforward. You see that we had 1 over the constant before the integration. So here you get 1 over 3, straightforward. But you can set this because you pass through the procedure. But straightforward, you can get this, and when you integrate sine, you get negative cos 3s plus c. You see how it is? If you have integral of cos 5s ds, you get 1 over 5 sine 5s plus c. That's what you're going to get. But be careful, in case there is squaring, don't go by that. Alright, so that is it. Let's keep on solving questions so that we will explore more. Alright, we will explore more. It's a gradual process, okay? Yeah, mathematics is a gradual process. That is why you start from kindergarten. When you start from kindergarten and you start by counting 1, you get to 2, so 1, 2. So at kindergarten, you'll be first learning from 1 to let's say 10. Then move from 10 to 20. Then we take you in all 1 to 20. Then you get to 100 like that. So mathematics is a process. Okay. So let's see how we are going to. I don't know. Is it example 4? I don't know. What matter is the question? 3s squared minus 1 over s to the power 3 minus s plus 4. Okay. Yes. Having this question to solve is somehow difficult. It's difficult. Hey, in mathematics, forget about how complex the person will appear to you, alright? And start applying what you know. You know that with this, the power here and the power here, you see something. Hope you can see something. So you can quickly go and choose your u. Your u is always inside of something, and the power is always above the one outside what? 1. So you can pick u to be equal to 3. And also the derivative of the u, the variable that will be inside of the derivative of the u will always be inside of the integral function. Are you getting it? when you take the derivative of the u, the result that you get, it will be included in the what? The integral function. Or let me put it this way, sometimes when you differentiate the u, the result that you get, the whole result can be embedded in the what? In the integral function. And this is the integral function. So having x to the power 3 minus s plus 4 du ds is going to be equal to 3s squared minus, integrate this, you get 1. But this is what? 0. Woo! I hope you can see something. This. So du is equal to, I love mathematics. So du is equal to 3s squared minus 1 ds. So you can see this, that is what? Du. So integral of 3s squared minus 1, the whole of this is u to the power 3 ds. And ds will be what? Ds will be du over 3s squared minus 1. So du over 3s squared minus 1. This will take away this integral of 1 over u to the power 3 du. You see, it was somehow, oh, it's too complicated. But it's just simple as this. I love maths. Let's continue. So now, having this, we can write this as this du. So when you integrate this, you add 1 to this, we get this. Then you divide by that. Okay? Plus c. But u is s to the power 3 minus s plus 4. So by substitution, negative s to the power 3 minus s plus 4 equal negative 2 plus c. All these over 2. Simple. Simple. Alright. Let's go to our next question. We are introducing something to you. Example 5. S 2s minus 1 ds. Please, I would like you to start to solve something, alright? Now, don't care about the reason that always you first the u is inside something, and sometimes to the u, the power of it one will be above of the outsider one, but sometimes not always. If it's above of it one, it's a correct u, and if it is same, if they are having the same power, it's a correct u. But if it's above of it more than 1, that is a wrong u that you are picking. For instance, here is 3 and here is like this. Or here, okay, yeah, something like this. This is above of it what? 2. This will not help you. But if it's the same, you will still get a nice thing, alright? But you need to just apply something. So let's go. Our u will be equal to 2s minus 1. So the u ds will be equal to, this is 0, this is 2. So ds will be equal to du over 2. I said no fear here, okay, no fear here, no fear here. So by substitution, s here is u 6, ds is du over 2, and the constant is half integral of s u to the power 6 du. From all the examples that we have solved, always the u cancel, the s cancel out, because the system says that we should translate the s to u, but we are still having s in it. And this is the case that nothing is going to help us to cancel it. So does it mean we can't solve it? Oh my dear, we can still solve it. Alright. In what way? Is that what you're asking? Don't worry. You know that u is equal to this. Then in the same way, you can make s the subject and come and substitute back to this. Let's see. Half integral of s u to the power 6 du, but u is equal to 2s plus 1. Sorry, minus 1. So 2s is equal to u plus 1. You are making s the subject. So we get s to be equal to u plus 1 all this over 2. So instead of writing s, we are going to write this. So half integral of u plus 1 over 2 u raised to the power 6 du. Are we now not having the integral function to be in terms of u? Exactly that. So apply your algebra. Here we can do something. Half integral of half u plus 1. Please, algebra. You can log this half out, and this half 2 can come and multiply this. So you get 1 over 4 integral of this will multiply this. You get u to the power 7 plus this will multiply this. You get u to the power 6 du. Beautiful. Alright, so when you integrate the inside here 10 by 10, you are going to get this. And don't forget to add your plus, please. Sometimes there are some people that when they get to this side, they multiply the outside inside of this, then they start doing the substitution. When you do that, you are not wrong, but make sure you reduce to the least form, okay? Because that's why you do algebra. And sometimes it depends. If the marks demand steps, you are going to lose those marks. So make sure you reduce to the least. So 1 over 4 integral of u to the power 8 over 8 plus u to the power 7 over 7 plus c. Here, if you multiply the LCM is like, it's like we want to find the LCM, okay? So, when you multiply this by 7, you get the LCM. And when you multiply this by what? 8, you get the LCM. So, to multiply this by 7, we want to achieve the same common what? Denominator. So to multiply this by 7, then I will undo it here. So 7 over 7 is 1. And multiply this by 1 is the same thing. Multiply the whole of this by 1 is the same thing. I want to multiply here by 8, so I will undo 8. So we get 1 over 4. Here 7u to the power 8 over 7 times 8. And I have an calculator here. 7 times 8 will give you 56. So we get here to be 56 plus here is 8u to the power 7 over 56 plus c. And 1 over 4, we can combine these two. 7u to the power 8 plus 8u to the power 7. All these over 56. You see this? Nicer than the first one. Alright, so now when you multiply 56 by 4, you get 2, 2, 4. So 1, 2, 2, 4. Then the inside will be 7 u to the power 8 plus 8 u to the power 7 plus c. But u is equal to what? 2s minus 1. So 1 over 2, 2, 4, 7. And in fact, we can even still reduce it here. This one, we can still reduce this. And how can you reduce this? Having this, we can factor u to the power 7 out. Before the substitution, we can factor u to the power 7 out. And we are going to get 7u plus 8 plus c. Algebra. So we get 1 over 2, 2, 4. Now let's do the substitution. 2s minus 1 power 7. Then 7. 2s minus 1 plus 8 plus c. So this becomes our final answer. So if there is a max for these steps, so that you can be able to get it. Good. Let's keep on solving more questions. Don't get tired. It's good to solve more questions. Good. So we can try our hands. We can try on integral. Which number is it? Number 6 or what? Sin s integral of cos s ds. Try on this. The u is always inside of something, so u is equal to cos s. The u is equal to what? Negative sin s ds. So we can get ds to be equal to du over negative sin s. Quick. So by substitution, integral of sin s square root of u ds is du over negative sin s. This will cancel this. So the negative, what's the constant here? The negative is the constant, so negative out, negative 1. So here we get u raised to the power half because I want to integrate it. Du, simple, not difficult. Negative. Now, when you integrate this, we get u raised to the power 3 over 2, and we divide all by 3 over 2. So apply your algebra to 2 over 3. To 2 over 3. Alright. Then we get plus c. So but u is what? Cos s. So we get negative 2 over 3 cos s to the power 3 over 2 plus c. And we can leave our answer as square root of cos s to the power 3 plus c. That becomes the final answer. Next. Okay. You can have a question like, please try this. S s square root of s minus 2 ds. Now, sometimes the question can straight you to a particular u that you should choose. After this, then the question will say choose u to be equal to square root of s minus 2. I know that from what you know, you choose u to be s minus 2. It will work for you. You come back and do the substitution and get it all right. But sometimes the question will restrict you to choose u to be this. And if you are restricted, there is nothing that you can do about it. So let's use u to be equal to square root of s minus 2 du ds will be equal to, this is the same as s minus 2 or half. That is why you don't need to forget your calculus 1. So this is just a general power rule. So this then repeat the inside, subtract 1 from this. So 1 half minus 1, you get negative what? Half. Then you take what? The derivative of the what? Of the inside. There is nothing difficult here, just your calculus 1. So this is going to give you 1 over 2 square root of s minus 2 times, when you take the derivative of this will be 0, this will be 1. So you get 1. So this is your du ds. Since we want to go and do the substitution, let's make ds the subject. So cross multiply. You will get ds to be equal to 2 square root of s minus 2 du. So alright, so having this, we can go and do substitution into the formula. So we have s over, now the whole of this is what? U. So we get u, and ds is what? We have ds to be 2 alright, that's that. 2 square root of s minus 2 du. So we need to get rid of what? All the what? The x, so that we can integrate it as respect to what? U. So when it happens like this, what will you do? No problem. We can still go by that idea. Now, but let's first simplify it small. This is the same as 2s square root of u minus 2, all this over u du. But u is equal to square root of what? S minus 2. So, to find s, what will you do? Square both sides. So you get u square is equal to b. Like whenever, to be a good mathematician, have confidence in your what? Solving. Okay? Let the concepts be there. So this you get s minus 2, because I'm sure that when we get to this side, we were scared. But here we get s to be equal to u squared plus 2. So this is our s. So wherever you see s, put this one there. Because sometimes the question can straight you to use that, knowing that you struggle in using that, but you still straight you to use it. So here you put s to be this. So here will be u squared plus 2 let's substitute it to this side. So we get 2 u squared plus 2, then square root of u minus 2, all this over u. Oh, sorry, this is x. So the inside here will be u square minus u square plus minus 2 du. So that is all that we are going to have for that. So let's deal with it with just algebra. So now, right, let's continue. So having this, the algebra is but let's continue. This time this, you get 2u squared plus this time this, you get what? 4. You get 4 here. Okay. And now you get this whole over u. Alright, let's continue. So this is like this, okay? Because if this is dividing the whole of this in the multiply, we can write this as this. Now, this is not anything too big, it's just simple. We can get here u squared plus 2 minus 2. I hope you can see that. Du. So here we get 2u squared plus 4. All this over u. Multiplying by this and this is 0. So you get u squared. I don't want to skip any step. Now here you are going to get 2u squared plus 4. In fact, before you take the integration, you have to make sure that the integral function is in the simplest form. So here you get this over what? U. And now this will cancel this. So we get what? U here. Beautiful. Beautiful. So, but make sure that this is, I don't want to skip a step. This is the same as this. 2u squared plus 4. All this over what? U. Du. Oh! Mass. So this will cancel this. So integral of 2u squared plus what? 4 du. Beautiful. Beautiful. And now we can take the integration because the integral function is now in the simplest form. See how it was? 2 bunch of stars. And imagine when we did the substitution. Imagine when we did the substitution. It's like 2 bunch of stars. 2 bunch of stars. But you have to have confidence in whatever what you are doing, and you see that this, you can write it like this, and with this and this will cancel, and you get u, and like that, this will cancel this, and exactly now we are here. You see, I can see that you are laughing. You are laughing now. Okay, so the integral is going to be equal to what? This is what? U to the power 3 over 3. U to the power 3 over 3 plus 4x plus what? C. Hey! 4u over c. Why not x? Because we are integrating as respect to what? U. Very good! But when you read this side, you can still factorize something. You can still reduce it, okay? Because here, we can factor u out so that we can get 2 over 3 u squared plus 4 plus c. But u is equal to what? U is equal to, we have even cleaned our back. U is equal to the square root of s minus 2. This is u. So therefore we get s minus 2, 2 over 3, and watch. U is s square root of s minus 2, and it's all squared. So here we get s minus 2 plus 4 plus c. Beautiful. So this becomes the final result of our integration. Let's keep on solving questions. That's why it's good to solve questions. So you see, you may think, oh, every day I will choose my u. So I will always choose the one that my integration will be easy for me. Sometimes you can be restricted on a particular u to choose, and that is what we have just find out. What example is this? I don't know whether it's 8 or whatever. That is not the focus. You're almost done. You're almost done. Integral of integral of 3s square root of 4s minus 1. Yes. So here, choose. I'm not saying choose, so from the question, choose u to be equal to square root of 4s minus 1. You are being restricted. Please don't go beyond the question. So, solution. U is equal to 4s minus 1 to the power half. So du ds will be equal to half 4s minus 1. Subtract from it. Okay, normally you don't subtract from it. Sometimes you will not even bring it. Please don't forget that. Okay, sorry for that. When you differentiate the inside, you get 4. So our du is just going to be this 2. So we are just going to get 2 over square root of 4s minus 1 ds. And you don't want, let me bring it here, ds. So by cross multiplication, we get 2 ds is equal to square root of 4s minus 1 du. So you divide both sides by what? 2. So this one will go. So we have ds to the this. This may be our last example. Then I will give you some questions for you to go and try your hands on it. So having this, by substitution, 3s, the whole of this is u, and the ds is square root of 4s minus 1 over 2 du. Du, ds, right, that is it. So from here, what are we going to do? We need to get rid of all the x's. And how are we going to do that? But u is equal to square root of 4s minus 1. So when you square both sides, you get u squared is equal to 4s minus 1. So 4s, you are looking for s. So s is equal to u squared plus 1 over 4. Very good. So by substitution, integral of 3s, we know s already, u squared plus 4, u squared over 1 over 4, u squared plus 1 over 4, u square root of 4, s is what? U squared plus 1 over 4. Watch what I'm doing. 4 to s is this minus 1. Is that all? All this over 2 du. How is like the s is fixed. The s is fixed. So now algebra. You take your time, okay? Now you can see that here, what we have here is just 3u squared plus 1 over 4. And since this is a denominator, this is also what? A denominator. So, okay, don't worry. Multiplying by, looking at the inside here, we have this will cancel this. What we have here is 2, and this 2 is multiplying this. Take your time, okay? This will cancel this. So here we get u squared minus plus 1 minus 1. Beautiful. In fact, the moment you see that in the square root, something will cancel to be left with u squared so that the square root will go. In that case, you say beautiful. Alright? That is why you are reaching the world with the beauty of mathematics. Mathematics is always beautiful. Alright. So 3u squared plus 1. This and this, you get 8 here. And the whole of this stuff is just u du. So now we can get 3u squared to multiply u squared plus 1, all this over 8 du. Oh, mathematics. But God bless Isaac Newton and Gottfried Leibniz. In fact, it's a world debate now whether it's Isaac Newton or Gottfried Leibniz who invented calculus. Alright, so the constant there is 3 over 8. And we have integral of u squared plus 1 du. So here 3 over 8 integral of u to the power 4 plus u squared du. Okay, so here we are going to get 3 over 8. Now take the integration and let's go back, block it here. U to the power 5 over 5 plus u to the power 3 over 3 plus c. As I said, let's reduce it. So common denominator. We can get here 5u. I'm now doing it straightforward. So 5, 25. Oh, we are multiplying that place by 3. Multiplying it by what is here, so 3 over 3. So 3, 5, 15 plus 5 multiplying this, so 5 u to the power 3, 5, 3, 15. Common denominator, algebra plus c. So 3 over 8. The LCM of, we factor what? This out. So we get u to the power 3 out. You will have 3u squared plus 5. All these over 50 plus c. Woo, woo, woo. Math is sweet. So here we multiply 8 by 50. We get 120. So we get 3 over 120. And that is 140. So we get 140, 1 over 40 u to the power 3, then 3u squared plus 5 plus c. But u is what? Square root of, that is u. So from the question, 4s minus 1 is u. So we now have 1 over 40 square root of 4s minus 1. Woo! All power 3, so 3 will be here. And this is 3. Now the square, so it will go, so 4s minus 1 plus 5 plus 6 plus 6. Therefore, we get this to be our final answer. Oh, Charlie, don't you laugh at that? Keep on practicing, and as we normally say, practice makes a man perfect. Keep on practicing, keep on practicing, keep on practicing, and you also get there. Alright? Try, make sure you try your hands on square root of s, integral of s, 5s plus 2 ds. So try this and choose u to be equal to square root of 5s plus 2. Yes, choose that. Choose that and you will love it. Alright, thank you. See you in the next video. Now, in the next video, we are going to talk about all that we have solved so far is indeterminate. It's indefinite what? Integral. That is when we don't have the lower bound and what? The upper bound. You know that if you have something like a, b, f of s, dx, here this is lower bound and this one upper bound. Now, for all the questions that we have solved, we haven't seen such cases, and that case is a definite what? Integral. Definite integral. Now, this is indefinite. Indefinite. That is why we normally end with what? A general solution. That is when in our final answer we normally have C in it, and that is what? A general solution. We will be back with what? A definite integration, and it's going to follow the same idea. Okay, so don't forget the one that we have learned. Thank you all, and see you in the next video. Until then, you are loved.